Hi all, as most of you probably know by now, my name is John Orr. My Yupik name is Naulach, which is what my children and my elders call me. Naulach comes from the word Nauk, which means roots, as in the source of growth. My roots are in Tanunuk on Nelson Island, but I'm speaking to you from Fairbanks, Alaska on lower Tanana Dene homelands. I want to start by briefly introducing and describing the fellowship. The purpose of the IARPC Fellowship for Indigenous Leaders has two main parts. One is to provide IARPC teams, and by extension, IARPC as a whole, with experts that possess perspectives that stem from deep place-based knowledge of Alaska. This is something best provided by Indigenous Alaskans, and the benefits those perspectives bring to the collaborative research community that we all work in is something that we should already be aware of. Second, and most important to me, is to provide Indigenous leaders, or as we say, elders in training, with the opportunity and institutional support to be able to participate fully and unimpeded in the IARPC community. This meant giving Indigenous leaders the time to be heard, the resources to be seen, and the support to be valued, which leads us to this very exciting moment. I want to thank the Education and Training Foundational Activity Collaboration Team and the Terrestrial Ecosystems Community of Practice for welcoming our two fellows into their leadership groups. I want to thank the Pillar Foundational Activity Team for laying the groundwork for this initiative. I also want to thank Harmony Weiner and Craig Jeichler for pioneering this fellowship and for breaking trail for all future fellowship cohorts. I would also like to thank everyone in or adjacent to IARPC that has provided support and guidance, both to Harmony and Craig, and now to our current fellows. You know who you are, and we value you. Finally, I would like to thank our fellows, Michele and Caitlynn, for stepping up to face this challenge. As an Indigenous person myself, I'd like to give a land acknowledgement that's inspired by my name and my roots. So I want everyone to take a moment to feel the earth pushing up against your feet, to sense it fully. I want you to remember from this point onward that that ground is the ancestral homeland of displaced people, the original stewards of this continent and its great bounty. I also want us to acknowledge that displacement does not always require direct action. Inaction and slow action will accomplish the same result. I want everyone to remember that colonialism is an ongoing process, and to consider how we might be unknowingly contributing to it. Each of us is Indigenous to some place, and my hope is that every day we can be mindful about how we might move forward in such a way as to ease the continued pain felt by those who once called the ground beneath us their home. So with that, I'd like to pass it over to our fellows to introduce themselves, provide an acknowledgement of their own if they so choose, and to borrow a phrase from Estelle Thompson from the native village of Pymute, to talk about the heart work that they are doing. And we're going to start with Dr. Michele Yatchmeneff.
Everyone, thank you, John, for that lovely introduction. So I'm going to be talking today about indigenizing STEM education using belonging. I'm Dr. Michele Yatchmeneff. Let's see here. I'm resting on the Dena'ina land today. UAA is where I work, and it's located on the ancestral unceded homelands for the Dena'ina, Otna, Alutiiq, Supiaq, and Eyak, or the Hachnu peoples. In my language, how I would say, I'm on Dena'ina land is Dinainam Tunangan Kugan and Gagiza. I live on Dena'ina lands, and my language is Unungam Tanu. I like to put how to say Dahachnu down in the bottom, because I think we're moving away from the colonized names, and this is what Eyak people would prefer to be called, and so making sure we're pronouncing that correctly for them. I have a picture of a crowberry or mossberry. In my language, it's called onsoch. The reason I like to show this land picture is because that's actually my Indigenous name. My background is I constantly wear black, and I love to pick mossberries in the fall time, and that's this time of year, and it's one of my favorite seasons because of that. So that's why I have that native name. So I'm Onanga. I go by she and her pronouns. I'm from King Cove in Falls Pass, Alaska. If you can see the little map up there, that's where I'm from in the state of Alaska. I work at the University of Alaska Anchorage as the Alaska Native Education and Outreach Executive Director. And then I'm the first and only Alaska Native in the world that we're aware of with a PhD in engineering education. There's only 4 of us who are Alaska Native with PhDs in engineering altogether, and 3 of us are actually working at the University of Alaska Anchorage as faculty. And I'm actually an associate professor. I did receive tenure for engineering, and I was the first to do that. Thankfully, my other colleague came after a year after me and got tenure as well. And we're working with the third one. I'm one of his mentors to help him get tenure in mechanical engineering. I want to acknowledge that when you're the first and only of anything, it's very difficult and isolating. And that's probably the reason why I took this journey, is to hopefully break that ground for students coming after me. I don't want to be the first and only forever. I want other students to come behind me, and so it is difficult, but I'm hopefully making that better for all the students that come after. Some background, I think, why we should care about some of the research that I'm doing in terms of indigenizing STEM education is that we have a high population of Alaska Native people here in the state of Alaska, yet our graduation rates for our students and our representation in STEM is very low. If we look at our high school graduation rates, they fall underneath the state average and also the national average. And then, we're being dramatically underrepresented in STEM professions and research. Our voice, therefore, is then missing from STEM education and research activities. And so I think it's imperative at the core, we try to figure out what helps and hinders Alaska Native students succeed in STEM so they can be represented. Some background at University of Alaska Anchorage. We received a 29% decline in our Alaska Native students, whereas we saw in all students only a 20% decline in the last 5 years. So again, another reason why I think this work is so important and should be focused on. In my process of helping indigenize UAA, this was a quote by Joe Nelson. He's works at the Sea Alaska Corporation. He said, "The students are not the problem. The system is the problem. We need to fix the system. This is why we are here. Alaska Native people need to be part of the solution and the driver." And I really want people to hear that, because I think oftentimes we deflect the problems onto the students when it's not their problem, it's the system's problem, and that's one of the things that I and my colleagues want to help with. I also like to acknowledge that anytime you're working in DEI work, it's usually a very personal process. My research is looking at Alaska Native students, and I see myself, being Alaska Native in them a lot. And I think when engineers do STEM research, oftentimes it's very clinical, it's very mathematical, and it can be very personal. But when we're working on DEI work, it's definitely very personal. This is actually a self-portrait that I drew, and oftentimes I have to resort to that because it helps me get through sometimes the challenges that I face daily in trying to do this work. One of the areas that I focused on in terms of my research was looking at the Alaska Native Science and Engineering Program ANSEP students. And so I want to share with you some of the background in that. It began in 1995 with one student. They're now working with thousands of students all across Alaska. starting in kindergarten and working all the way through the PhD. Their goal is to provide an excellent education and a life of unlimited possibilities for every Alaskan. So I'm actually an ANSEP alum. I got, with their help, a BS degree in civil engineering at UAA, and then also a master's of science in engineering management. And then they actually helped provide the financial support and other support when I went off to get my PhD at Purdue through the Grow Our Own PhD program. Some other background is that they have all of these components. They work with K through 5 students, oftentimes remotely, doing activities via Zoom and other things like that. They'll send out packages to those students, and then they can do activities via Zoom after they've received their packages. We also bring in middle school students from all across the state to come stay at the University of Alaska Anchorage and stay for about 2 weeks and do STEM activities with either faculty or local agencies and partners that we have. And then they can come back every summer and actually do a focused experience with a specific career that they might be interested in. For example, the medical area or the engineering area and so forth. And then our students actually can go in high school and take dual enrollment courses. They take courses that count for their high school towards graduation and then also towards college. And then we have students who come in the summertime and do a bridge experience where it's an internship with one of our partners, and then they transition to being a university student. And we offer scholarships to those students for STEM degrees, but also now business degrees, because we have a lot of Alaska Native corporations that also need business people to be able to fill in the roles of our CEOs and all of our HR people that are working in those agencies, and that's very important work. And then students can also go on to do the Grow Our Own PhD program, which is they get financial support to go off to get their PhD, and that's what I did. I like to share that one of the things that's important about this is that a lot of programs are inspirational. They might provide an experience, but it's also the educational part that needs to be included so that students are prepared to go to college and then get that help while they're at college and feel like they belong at the university so that they can continue and be retained and get their degrees. So this is my previous research. I looked at motivation of Alaska Native high school students, and the motivation theory that I looked at was self-determination theory, and it talked about students needing autonomy, being able to select the things that they do in order to want to do those things. They talked about competence, believing in yourself that you have the ability to do those things, and relatedness was the belonging piece. In all the research that I looked at for this theory, the main thing that students always talked about is the autonomy and the competence part. So the being able to decide what you do and then also believing in yourself. But when I did my research and interviewed Alaska Native high school students about their experiences in STEM, they all talked about the belongingness part. That was their main conversation, and what I actually I think progressed this theory to include Indigenous students and realized that belongingness was a bigger part for them. And so when I became faculty, I expanded on this and focused on then just the relatedness piece and wanted to look at that specifically for high school students. So some of my theory looked at Macmillan and Chavez's sense of community theory. And what I wanted to figure out is what are the characteristics for that Alaska Native students tell me, and then Alaskan high school teachers tell me helps our students feel like they belong in math and science classrooms. And the reason I focused on high school is because we're not going to get students into STEM if they're not doing math and science courses in high school and feeling like they belong. Another thing is I wanted to see if that helps them consider taking more math, more science courses, so that they can hopefully consider STEM and persist when they get to the college. I wanted to interview students from several different communities, including village, hub, or road communities, and then also urban areas. If we look at the indigenous populations, as the population gets higher, the also indigenous population there gets lower. And same with the availability of math and science classrooms. As the communities get bigger, the more math and science classes they have. And then ANSEP kind of didn't fit in this chart, but basically they have a large amount of Indigenous students and then also a high number of math and science courses that they can offer. One of the other things that I looked at in terms of these communities is that if we look at ANSEP and we look at village communities, their math and science courses are inside their Indigenous communities. And as we get larger populations, that is kind of the school, and the math and science courses are slowly, they're being more and more further out of the Indigenous community. And so I wanted to look at all three types of communities and see what the students were saying about math and science belongingness. So looking at some of the results and interviewing these students, interviewing the teachers, I first looked at the village students, and their main thing is that teachers didn't help them feel like they belonged at all. They talked about how the teachers cycle in and cycle out. They don't give them any encouragement whatsoever to excel. They don't give them any encouragement or expecting them to pursue post-secondary education. They also talked about their Alaskan Native culture being incorporated into their community and also into their school, and it was well respected. They all had the lowest level of math courses available and completed. I actually looked at what courses the students that I interviewed completed, and it was at the lowest level of all the students I interviewed. And it was also, they didn't have very many math and science classes available to them to be able to take. If we move to the ANSEP group, what they focused on, and when I talked to them, is that their classmates were the ones that helped them feel like they belong. They talked about fun. They talked about how helpful they were in working together. They also talked about their teachers, that they could be helpful, but that they had to do both lecture and group work. They explicitly said this. They needed occasionally quiet time to comprehend some of the techniques and things that they would need to learn, and that lecture was probably the best way to receive that information. But in order to get good at it, in order to be able to be successful in the class, they talked about having to do a lot of practice and doing that in teams, so that they weren't isolated and they could actually call math and science fun, which was really great. Also, their Alaska Native culture was well respected. They talked about the artwork. They talked about foods and all those kinds of things being represented and then also respected. And they had the highest level of math courses available, and they were the students that had the most math courses completed. They also had a high amount of science courses available to them. And then when we moved to looking at hub and road, students and interviewing them, and also the teachers, again, they said that teachers can help them feel like they belong, but they have to seem, like they have to show that they care. They also have to provide that balance in the classroom between lecture and teamwork. And they also talked that their culture is somewhat respected. I think the main thing was, if they had a club or if they had other students that they could work with, they talked about their culture being respected. But some of the schools, specifically the road schools, they didn't see their culture oftentimes in their classrooms or their schools. And so they said they didn't feel like it was respected or represented well. They had a moderate amount of math courses available and also that they completed, and also a moderate, sometimes low availability of science courses, depending on whether it was a hub or a road community. For the urban students, this was surprising to me. They actually said that the teachers do help them, but when they have a teacher that has teachers' pets, they don't feel like that teacher, especially if they're not the pet, they didn't think that they were helpful whatsoever. And they said that their culture was somewhat respected. And they talked about that if there was clubs or Native Youth Olympics as the reason why they felt like their culture was respected, is because they had places they can participate in their culture and learn about their culture. They had a high level of math courses available and completed, and then they had many science courses available as well. And so not the highest level, but a lot of science courses. And then when we're talking about institutional change, one of the things that we're working at the University of Alaska, and the reason I like to bring this up is that, we need to focus on all of these areas. It needs to be all of us working together in order to have institutional change. And so the Alaska Native Success Initiative was launched about 2 years ago at the University of Alaska, and it's all of our institutions. I'm the lead for UAA, but I have this highlighted as one of the things that we're focusing on. These are our 3 priorities at UAA, but preparation is one of the key pieces. I think as a higher institution and location that I'm at, I think people think that preparation is not something that we should be focused on. But if we look at that information, students who are unprepared that go to college, their likelihood of ever succeeding or getting a degree or certificate is very, very low. And that's not just in Alaska, that's any institution or school that we're talking about. And so to me, it is our responsibility at a higher ed institution that we need to be concerned about preparation. And again, it needs to be all of us working together on this. So whether it's pre-college, institutions, higher ed institutions, and then also our community, our Alaska Native community partners, but also the communities that we all live in need to be a part of this. So coming back to why we should care about this, in my research, I think one of the main things is that students, in order to consider STEM, belongingness is very, very important for them to even consider STEM. So even at the high school level or the middle school level, they need to feel like this is an option for them. So whether it's seeing themselves, whether it's having that group of students that they can work with, also having a place to land when they come to the university, seeing that there's a community for them to belong to, they find that very, very important in order to consider it and then also persist when they're going through their degree programs and then considering their careers. They also said that, lecture and group work was really important in terms of STEM learning, and that both options should be provided to students, when we're thinking about our classrooms at large. And then also natives need a voice in STEM. And I think, I talk to students and there's the research around this. When students choose to go to college, oftentimes it's not just for themselves, an advancement of themselves. It's an advancement for their community, advancement for their family. And so they choose usually a pathway that's not just for them, but for everybody that they care about and touch. And so it's important if we need their voices included in STEM education, because they're the ones who are going to be doing, climate change solutions and any type of engineering or STEM work that's happening on native land. They should be a part of that, and they should have the background and skills to be able to be included in that. Some of the best practices that I found was that we do need institutional change. We do need things that are across the board to help us have an impact for our Alaska Native students. We also need to infuse Indigenous ways of knowing into our STEM education, all along the process, not just, higher ed, but everywhere. And I like to bring this up, this instructor here is a renowned artist, June Purdue. But if you're learning about art, you're learning about hunting, what you need to do is usually hands-on learning. And we need to remember that when we're talking about doing STEM education or education in general, is that in order to, I think, help students learn something, is that we need to consider that hands-on learning when we're teaching courses. Also, that we need to be working on indigenizing K through 12 in higher education at every level. All of our teachers at UAA should be doing this. We have an indigenizing education program at UAA, and also having indigenous teachers, having programs that work on that, so that we can have our community members go back to their communities and teach their students. And then also having Indigenous curriculum all along the way as well, I think is very important to our students and how we begin to decolonize a lot of our work. So in closing, I want to say that using a longitudinal model, considering, K through 12, higher ed, our community, our industry, they all need to be part of the process. And, I know there's some challenges around the nation in terms of DEI work. And one of the things is we know that what can help Indigenous students or Alaska Native students will help all students. This isn't just localized to Alaska Native students. It will help every one of our students by doing this. Also, that community is really important to our students. Working together is an Indigenous value that they hold to themselves, and they want to be able to do that and as they move forward in their education. And then also why students consider and pursue STEM. And I like to say this is that our ancestors see us, and that it's important that we consider that and to always learn. So this is a picture of me. Actually, I'm in my 40s now, and learning my language and also learning my dances. I focused so much of my earlier life on my career and my studies that I didn't get to experience that. And today I actually get to do it. So I'm nowhere as eloquent as the young dancers, but I push myself to learn it and practice it and learn how to make regalia and all those things, because it helps us. So Kungasukuk, thank you. This is my email if you would like to reach out and get a hold of me. But I want to thank you for listening to that. And I just have a couple of other pictures. This is my background picture, but this is a picture of King Cove, the land that I'm from. And I just want to acknowledge that. And then here's some great pictures of food, because I love the food and it's one of my favorite things. So thank you, everybody, and I'll stop sharing this. And I guess I could pass it on to Caitlynn. Caitlynn?
Thank you so much. Yeah, why don't we go ahead and do we want to take a few questions just for Michele first? Maybe on stuff, anything specific to your talk. And then at the end, we'll kind of do some questions about that would be kind of joint for both of you. Any questions? This is really interesting work, and I really appreciate you talking about it. And I was really interested in, you talked a little bit about this, you've really focused on kind of Indigenous students and surveying them and talking with them. But you said it would be applicable to other students as well. And I can see this kind of branching out into more people and more being used even more. Do you see a way to kind of to bring that all together?
Well,
Like
multiple things, I think. For me, it's like, where can I have this impact in my sphere? And hopefully help other people see that. So whether it's, right now the college professors that I work with, I'm working across, all of UAA. But I work with UAS and UAF too. So making that point known and trying to work with them to do that in their spheres. So I've worked with the writing department. They've actually done, they've gotten training on how to do anti-racist work in their classrooms and start thinking about Indigenous projects that they can incorporate, in a writing course. And so it starts from there, having this impact in my sphere, and then hopefully it can ripple and make its way to the other locations. And then, it's not just me doing this work, it's other great people. I talked about the Indigenizing education certificate that we have in graduate program, and this is for all teachers to be able to take and incorporate into their K through 8 classrooms. And so that, again, that's I'm hoping that teachers will want to do that and actually take that upon themselves to start implementing that into their classrooms. So it's going to take some time and work, but I think as we see how impactful this is for our students, not just Alaska Native students, but all students, I think this could go a long way to start getting incorporated everywhere.
Yeah, that's awesome. Thank you so much. And I guess we'll pass it over to Caitlin, and then we'll do some joint questions at the end.
Hey, Liz, we have Kitty has her hands up. Can we let her
Oh, yeah.
ask a
Yeah,
question?
go ahead.
Thank you so much. Thank you for your talk, Michelle. That was really interesting. I do not live in Alaska currently. I'm at Fort Lewis College in the Four Corners region, and work in science education and also environmental science. And I'm curious if there are other, you mentioned the course and some other resources. I would love to learn more about resources or ways that I can network and learn what you're doing and more about what's going on in Alaska, and see if there are ways that I can help translate it, especially to the elementary education instructors that I teach as a professor.
Awesome. Well, perfect. I think I can chat with you offline, and then I can send you some information. I don't want to take up Caitlin's time, but definitely there's a lot of great things going on out there.
Thanks. I'll send you an email.
Thanks so much. All right, Caitlin, take it away. I don't hear you yet. It's kind of coming in kind of scratchy. Can others hear? Maybe it's just
Not yet. Do you want to try with your video off? Maybe that would help with.
Okay.
Okay.
Better?
Yes. We'll keep
yeah,
talking, but we
that's a
can hear
lot
you for now.
better. Thank you.
Okay. I can also call in very quickly.
We can hear you.
No, this is good.
Okay,
Just with your video
great.
off, we can hear you just fine.
Okay, great. My name is Caitlynn Hanna. Ulalotak Uvanga Totuk Nolokni Chisiga Caitlynn Hanna. Inunoktunga Fairbanks me. Pigit Dogro Mingaronga. My Inkback name is Tautuk. I am Inkback. My family is from View, but I live in master's student at the University of Alaska Fairbanks. So I live and work on the land of the Lower Tanana Dene, and the work I'm doing for river rusting in the Wulik River basin is for the Inkback, people and their land and my homelands. Okay, I am a co-lead for the Terrestrial Ecosystem Community of Practice. And currently we've been working on planning a workshop for 2025. So keep your eyes out for that. And the workshop is going to be on Arctic terrestrial hazards and their impacts. I'm really sorry to Daryl and Tony for not being in this photo, but this was this summer, this fall in Fairbanks with some of the other co-leads and John Orr. Okay, a quick introduction to river rusting. I'll keep this pretty brief. Maybe some of you had seen the presentation by John last week on river rusting. So what is river rusting? That term refers to rivers turning orange or red because of a rusting effect happening within the water itself. There are other terms that I used and what have been used. So another is an increase in total dissolved solids. So that is the dissolved minerals occurring in the water. And that is something that can be quantified, it can be measured. So I'll also be using total dissolved solids, or TDS for short. And another term of foresting is acid rock drainage. I have a little photo in the upper corner for the Brooks Range and where that is occurring in Alaska, but I'm looking at the Wulik River basin. So how is river rusting occurring? So this is a really great graphic from a paper that was just released the beginning of this year, metal mobilization from thawing permafrost to aquatic systems, ecosystems, and driving rusting of Arctic streams. Let's get in and zoom up closer to this. So the going hypothesis of how this is happening and how it is happening is because of permafrost thaw, a thing of the active layer, which is the layer in the ground that changes seasonally. In the summertime, it kind of thaws out a little bit. It's the top layer. And in the wintertime, it freezes back. But as changed, the permafrost table can lower into the ground or disappear entirely. And what that happens is that there were minerals in the ground that were already there that were held in place because of the permafrost, but now they're being exposed to moving the minerals into the groundwater, and then that will go into surface water. And then once it hits the surface water, it oxidizes, and you can see the rusting effect happen. So on the left, you have normal conditions where the minerals are held in place, and because permafrost doesn't allow water to flow through it. So you can see it's just kind of going through the active layer. But in this right-hand corner, you can see the groundwater is flowing through these minerals now and going into the stream. There are a few features that you can see this happening by is point source, where you have a groundwater acidic seep occurring. It kills the vegetation, and that causes a feedback loop for permafrost degradation, permafrost thaw, and it can be really acidic and very orange. And you also have the lowland processes and the processes happening at the headwaters. And this is impacting the water quality. And it has many implications throughout. I mean, everything that has to go to this ecosystem it's all interconnected, and it all impacts everything in many ways. So for people, this impacts the drinking water stream. It puts the downstream communities at risk that rely on rivers, surface water for drinking purposes in permafrost locations. All drinking water is typically coming from surface water. And this can also impact the aquatic food web. The salmon their eggs don't really hatch in really high concentrations of river rusting, and there is a possibility of this happening, of bioaccumulation happening as it uptakes into the ecosystem and gets more concentrated in larger organisms. And this can impact subsistence fishing. So maybe the salmon are being impacted, there's less salmon, and they could have large concentrations of these dissolved minerals. It is in Northwest Alaska. You can see the red outline. The entirety is the Wulik River basin, and it's broken up into the different headwaters happening here. Red Dog Mine is located within the Wulik River basin. It's located 90 miles north of the Arctic Circle, and the sedimentary rocks house high-grade zinc and lead deposits. The mine has no at all, but what is really fortunate for my work is they have heavily instrumented the creeks in the area, and they have been able to kind of pick up and start to get an understanding of how river rusting is occurring. In the mid-1950s, the mine was actually discovered by a pilot who saw like rusted rivers. There was no term for it then, but he saw these like really red rivers, and he reported back and said he saw that, and interest was piqued for the area, and the mine became operational in the late 1980s. The focus of the study is to determine if the change observed is a short-term ongoing talc formation. So is this happening just now? This kind of started in 2018 roughly is when it was really documented, or is this a more long-term thing that is going to continue with permafrost degradation and continue into the future? And I tried to look for a link between observed changes in climatic factors such as warming temperatures and increased snow accumulation. And the aim is to understand the underlying mechanisms driving these changes, focusing on talc formation. Talcs are areas in the ground that will thaw out, but eventually it freezes back. And also looking at deep fracture zones, because of the complex geology for this area and how the brick terrains formed, there are like a very big fracture zones, and they could have been filled up with ice, permafrost. And as that thaws, it creates kind of this channel. So the hypothesis is for this lower photo, Nick Seep, it's a groundwater seep. So this assumption is that there is a fracture zone there, and groundwater is upwelling from it and picking up these minerals from that fracture zone. And this is an extremely acidic seep around a pH of 2. This is the data locations that I used. As I mentioned, Red Dog Mine has instrumented and installed different monitoring systems around the mine, which has been able to kind of strengthen our understanding of how this is happening. So there is the West Fork Iglarock Creek boreholes, where they have installed thermistors that monitor the ground temperature. Then they also take water quality samples from West Fork Iglarock Creek. There is Nick Seep, again, like I mentioned, they have ground temperature monitoring and water quality monitoring in that location. They have many stations, but I've kind of keyed into station 150. It's a gauge station and water quality monitoring. And then they also have a meteorological station, which measures air temperature and precipitation. Here is some of the climate data for the location. We have the mean annual air temperature. It is increasing. I have Red Dog Mine and Kotzebue. Kotzebue is a very close community with a long history of monitoring, longer than Red Dog Mine. So that is also a great place to reference as well. And Red Dog Mine and Kotzebue have similar data for mean annual air temperature and somewhat similar data for precipitation. So you can see over time, the air temperature is increasing. And I've also calculated the yearly air freezing index and air thawing index. Air freezing index is the potential of freeze. air thawing is the potential of thaw based on air temperature, so above or below 30 degrees Fahrenheit or 0 degrees Celsius. For the air freezing index, that is decreasing, so you're having less freeze. The air thawing index is very minimally increasing, but not as dramatically as air freezing. So what that shows you is that the not being as impactful compared to the freezing. So you have the thawing, but it's not freezing back as hard as it has previously. I also have the snow accumulation here that is also increasing, but it is fairly variable year to year, and that's pretty important for permafrost. I have a remote sensing and permafrost modeling aspects of my thesis. I used planets, CubeSats to look at the changes seasonally and annually of river rusting for the Iglorak Creek. And I've discovered the near infrared red-blue band combination highlights river rusting very well. So in this orange circle, you have the true color image and also the false color image that I use the band combination for. So you can see the river rusting happening fairly clearly with the true color, but it's even more highlighted with the band combination. And then you also see this creek over here that has no river rusting coloring, and it doesn't highlight as well. Methodology for that is I took helicopter images with that they visually identified river rusting and gave the GPS locations. I lined that up in time and space for the CubeSat images. And also, so I could compare the spectral profiles yearly and seasonally to the spectral profile and make sure that I'm actually looking at river rusting. And then I hand delineated where river rusting is happening on the map. So this is August 2017. 2018, no, sorry. So this shows you seasonally and annually the changes. It's pretty variable and fairly dependent on a few, many complicated factors. So I have compared the climate data and total dissolved solid concentrations measured. The climate data is for the Bonds Meteorological Station, and the total dissolved solids were measured at Station 150, as I mentioned previously. You can see there is a time lag between air temperature and total dissolved solid concentration. As temperature increases, total dissolved solids also increase. And there is an inverse relation with precipitation and discharge. So with more discharge, more rain, it is kind of diluting the water and lowering the concentration. And with less input from precipitation, discharge, the concentration increases of total dissolved solids. So this is the modeling. I use the Geophysical Institute's Permafrost Laboratory GIPL. It is a quasi-translational spatially distributed equilibrium model. It can calculate the active layer thickness and mean annual ground temperature. It counts for cover vegetation, soil moisture, and soil thermal properties. The calibration is very cyclical. You start with the initial approximation, you come up with your thermal properties, you model it, and the model computes the temperature. So in the black line, that is what the model computed, and in the red line is the observations. It is what a borehole measured at the same place in time. You look at what is different between the model and the observation, you remodel it, and you just keep doing that over and over to kind of try to understand what's happening and get a close model to what was measured. These are the boreholes that I used for the permafrost model. And kind of, this is the geological map that the USGS has. This is where the boreholes are located and the different formations and thrust faults for the area. When they installed the boreholes, they took photos. From these photos, you can get the vegetation type, and that will give you an idea on organic matter, hydrology, and possible snow depth. When they installed the boreholes, they also documented the soil descriptions of what they encountered and at what depth. And from that, you can try to get a realistic soil thermal properties for those minerals. This is an example of one of the boreholes and the model that I created for it. It's not perfect. It's really, you can never get an exact perfect replica of what is actually happening and the observations that are measured. But you get as close to reality and what the general understanding is for soil thermal properties of the minerals that are there. You cannot create models that are not based in reality. And these are the different nodes on the thermistors and the temperature measured as different depths. From the models I created, I have the modeled temperatures at depth 2.74 meters at West Fork Iqaluit Creek compared to the total dissolved solids concentrations measured from the same creek. This is a pretty busy image, but I am showing different vegetation classes for when you have like a also taller vegetation, and then these two lower or shorter vegetations. And then down below, you can see the total dissolved solids. Let's simplify this a little bit more to look at it. So I have a taller vegetation in red and shorter vegetation in blue, the upper and lower. You can see they are increasing in temperature annually, but again, some variability. Total dissolved solids are also increasing over time. And from here, you can see the impact of temperatures in the ground impacts total dissolved solids. So this winter of 2018-2019 was there was a lot of snow accumulating on the ground, and snow is very insulative. And so the temperature in the ground wasn't very cold. Then you had a very warm summer and air temperature following that. And again, winter of 2019-2020, there was even more snow and a warmer summer. And following those, you have an increase in total dissolved solid. But the winter of 2020-2021, there wasn't as much snow. And so it was able to freeze more deeply, freeze harder. And then you had a less warm summer, followed by, again, a very cold winter. And the total dissolved solid increased. They did not go back to what was being measured in 2015, 2016, but they did start to decrease. So again, there's really complex interactions happening between climate and hydrology that is influencing total dissolved solids, but it is heavily linked to heavy snowfall and subsequent warming on total dissolved solid levels and on permafrost and hydrology. It's important to consider the climatic variability and understanding the environmental changes in cold regions. And total dissolved solids increased in the Wulik River basin could mean more for broader permafrost and hydrological dynamics. And there's a need for further research to fully comprehend the complex interactions and the possible long-term implications of river resting. Thank you so much. That is the end of my presentation. I'm sorry, we are very close to end of time.
Thanks so much, Caitlin, for your talk too. Thank you to both of our presenters. Since we are at the hour, I think we could let people go if you need to, but if there are a few folks that want to stick on for a few minutes, we could do some Q&A. That works. And I think I saw some in the chat. Let's see. Is anyone looking at microbiological impacts from acid rock drainage? We are interested in studying the Alaskan scenario as a terrestrial analog to Mars because this permafrost thaw driver is a more convincing analogy than the Rio Tinto Spain Mars analogy.
Yes, there is another research group who is looking a little bit closer at microbiology. Again, there was that presentation that happened last week. I am not a microbiologist at all, and that is extremely over my head, but they are looking at that.
And I think I just saw another one in the chat. Speaking of belonging, anyone heading to AISES in San Antonio in October? I don't know which acronym that one is.
Yeah, unfortunately, no, I'm not going to ACES.
Okay. Caitlin, have you had a chance to talk with John about his talk from last week and kind of connect on some of the research that you're both doing?
I haven't talked to John, but I have talked to someone else that he is collaborating with, Roman Dial, and we have shared information and hopefully working towards writing a paper together with me and the people on my committee and from UAF who are also doing this work. But I definitely want to connect more with John.
That's awesome. And then does anybody else have a question? You can just unmute yourself and ask it if you'd like.
Yeah,
I think there was just one follow-up, Cynthia, you might be able to be asking just now about the name of the microbiologist, Caitlin, that you might have mentioned at the beginning of your answer.
Yes, John O'Donnell previously gave the presentation. I don't know who the microbiologist on the project is, but I do know that they have kind of talked about the wetlands and the microbiology within wetlands, where there are little organisms that convert the iron particulates. Yes, so I would look for his presentation from last week, and he's with the National Park Service. If you Google John O'Donnell, or if you refer to my presentation in the beginning, I referenced the paper that was just submitted.
And then I was just going to ask a little bit just about both of you, what your experience has been being a fellow, and how you've felt that your fellowship has worked, and any thoughts you had on kind of speaking as one of the fellows from this year.
I have had a really great time. Thank you so much, Liz, for and every one of the Terrestrial Ecosystems team for welcoming me so well and helping me try to understand IARPC. I was not 100% knowledgeable of IARPC before I joined, but I've gotten such a better understanding of it. And also I've been able to meet some really amazing people, increase my connections to everyone within Arctic research. And I'm really excited on the workshop and learning so much about planning it and all of those many things you have to consider for it.
Yeah, and I'll just echo that. It's been amazing. I encourage this to happen in more locations and more places. I just think it's a great opportunity to I think get that information out there, but also have all of us working together to work on research topics and things that affect the Arctic. And then and it's increased my sphere of folks and people, and just been able to I think work more efficiently in the job that I do every day, just having that extended network of people.
Well, thanks so much to both of you. We've gone over time a little bit, but I appreciate those who could stay on. And both of your talks were really interesting, and I've learned a lot. And I would just let everybody know that I think, Tony, you were gonna put it up, the permafrost team has a meeting in October. Do you wanna put that up on the screen real quick or link it in the chat?
Yeah, I'll drop a link in the chat, but it'll be on shallow groundwater resources and permafrost, October 8th at 10 a.m. Alaska time. So that page is live on the IARPC collaboration site.
All right, thanks so much. Well, we hope to see some of you back again in October. Thanks a lot.
Thanks, everybody.
Bye.
Thank you,
Bye.
Caitlynn. Thank you, Michelle.
Thank you
Thank you,
both.
John.
Thank you for the great talks.